We've been focused so far on equations. Now we're going to transition to inequalities. And we're going to focus first just on ones that are one step and require adding or subtracting. So it is vitally important when you are working with inequalities, remembering the difference between the greater than sign and the less than sign. So one illustration some teachers use is you think of this as like it's an alligator's mouth. You know, there's the back of its jaw at the point, and these are its two sides of its mouth wide open. It's always going to be aiming to eat the bigger of the two things. So this would mean the bigger things on the left. This would mean the bigger things on the right. And when you're graphing these, if you do greater than or less than, you use an open dot. Also, one other way you can remember less than and greater than is this sign almost looks like a capital L for the word less. But whichever way you remember, it's up to you, but it's vital that you do remember it. Now, back to the graphing thing. If it's greater than or less than, you put an open dot like you see here and here. Those are open dots. If it's greater than or equal to, that's what the extra line means. They're basically combining the greater than and the equal sign into one thing. So greater than or equal to, or less than or equal to, use a closed dot. That's like the first two we see right here. Okay, so our first task is to match the inequality to the graph of its solution. So I'm going to choose to just solve these and then see which one it goes with. So right now it's x plus 11. As far as today's lesson, since we're just adding and subtracting, this is really done exactly the same way we do equations. So adding 11, we do the opposite and we subtract 11. So that leaves x is greater than 5. Okay, so I know it's going to be an open circle, and I know the open circle is going to be on the number 5. So right away, I know C has to be the answer. Greater than also means we shade numbers bigger than 5 to the right. So this one goes with C. Okay, for number 2, x minus 6. So the opposite of subtracting 6 is adding 6. That gives us x is less than 7. Okay, so we need an open circle or open dot, and it needs to be on the number 7. And it's going to shade numbers smaller than 7. So that means our answer is E. You can also think about these almost as the end of an arrow. And the arrow is pointing. I didn't do that very well. That greater than sign, if you think of it like an arrow, it's telling you which way to shade. It points that arrow that direction. This one was an arrow this way, so that's why we shaded this way. Number 3, we subtract 2, because that's the opposite of adding 2. So we get x is less than or equal to negative 5. So we're looking for a closed dot this time, and we're looking for it on negative 5, so that means we look up at A, because it's got a closed dot at negative 5. Number 4, we're adding 3, so the opposite is subtracting 3. So we get x is greater than or equal to negative 2. So we're looking for a closed dot on negative 2, so that's why we'd go with B. And our last one in this set, we add 1 to both sides. That's the opposite of subtracting 1. We get x is less than negative 6. We're looking for an open dot because there's nowhere equal to. It's on negative 6, so that puts us with D. Okay, now after we solve them, instead of matching it to a graph, we're going to actually graph them ourselves. So we start by adding 5 to both sides. That gives us D is less than or equal to 6. So because it's got an or equal to, we put a closed dot on the number 6. And since it's less than or equal to, we shade it to the left. If you want to shade just above the line instead of right on the line, that's fine. Just make sure it's clear which direction you're going. Okay, for 7, we're adding 9. The opposite is subtracting 9. So we get t is less than negative 1. This time we need to do an open circle because there's no or equal to. We put it on negative 1. And it's less than, so we shade it to the left. So less than, shade left, greater than, shade to the right. 8, a minus 7, opposite of minus 7 is plus 7. So we add 7 to both sides, we get a is greater than negative 6. So put an open circle, because there's nowhere equal to, put an open circle on negative 6, and we shade that direction, because it's greater than, so we shade it to the right. Okay, 9, w minus 1. We add 1 to both sides. W is less than 5. So we put an open circle on 5. And it's less than, so we shade it to the left. Okay, continuing the same thing here on the back. Now, the reason I did these first two has to do with where the variable is located. So I'll show you what I mean. We have k plus 3. We want k by itself, so we subtract 3 from both sides. So we do 1 is greater than or equal to k. Now, I would recommend you flip this around and put the variable on the left. That makes it easier to graph. So 1 is greater than or equal to k is the same thing as saying k is less than or equal to 1. So these two are identical in what they are saying. This one's saying 1's bigger. This one's saying k is smaller. Well, both of those are true. So I think it's much easier because you can only use the trick about the arrow if the variable's on the left. So you can figure out the dot pretty easily either way. We know it's going to be closed because it's got our equals to, and it's going to be at 1. That should be clear whichever one you're looking at. But as far as which direction to shade, I think it's more clear with this one because we want to do what the variable tells us, which k is less than 1, so we go to the left. And I feel like that's more clear and easy to see when it's written in this form than in this form. So we'll do the same thing on number 11. We want b by itself, so we add 4 to both sides. Get negative 5 is less than or equal to b, which is the same thing as saying b is greater than or equal to negative 5. So notice in these, when I reverse which one's on the left and the right, I also reverse the inequality. This is telling us 1 is the bigger one, so is k is the smaller one, which works and is true for both of these. This is saying negative 5 is the smaller one. This is saying b is the bigger one. Again, that's true in both cases. So, closed circle because the or equal to, and it's at negative 5. And it's greater than negative 5, so we shade it to the right to show the greater number, the bigger numbers. Numbers bigger than 5 are the answer. Okay, 12. We want to get x by itself, so we subtract 4 from both sides. We get negative 6 is greater than x, which is the same thing as saying x is less than negative 6. So I put an open dot or open circle at negative 6. And x is less than that, so I do it to the left when I shade it. Okay, last one, 13. Notice there's a variable on both sides. We talked about this with equations as well. If there's a variable on both sides, the best thing to do is to get the variables together first. So I'm going to subtract y, or 1y, from both sides. 2y minus 1y is 1y. I get y is less than 2. Now this one already has the variable on the left, so I don't have to change anything. I put an open circle because there's no or equal to at 2, and I'm shading it to the left. Okay, this says define a variable. That just means, for my purposes, just saying choose a variable. You can use the letter n, x, t. You can pick I'll probably just use n or x on these, but we'll write an inequality based on the sentence and then solve it. So a number, that's where I put my variable, decreased by 10 minus 10 is greater than negative 5. So a number, n, decreased by 10 minus 10 is greater than negative 5. So we add 10 to both sides, and we get n is greater than 5. 15, a number increased by 1 is less than 9. So we subtract 1 from both sides. Sorry about that. And we get n is less than 8. Okay, 7 more than a number, so I'll say 7 plus n is less than or equal to negative 18. So we'll subtract 7 from both sides. We get n is less than or equal to negative 25. Okay, and I want to point one thing out. I didn't subtract because I saw that plus sign there. I subtracted because it was a positive 7. So the operation I do doesn't have to do with what comes after the number. It's whatever comes before the number, whether it's a sign, positive or negative, or an operation like plus or minus. Okay, 20 less than a number. Remember, this is that tricky phrase where we do things backwards. So it's not 20 minus n, it's actually n minus 20. Because that's 20 less than whatever number we have. Is at least. At least. So you gotta make sure you understand what that means. At least means it's 15 or more. So it's greater than or equal to 15. So then we add 20 to both sides. We get n is greater than or equal to 35. Okay, a number plus 2 is at most. So at most would mean it's 1 or smaller, so less than or equal to 1. And we subtract 2 from both sides. We get x is less than or equal to negative 1. Oops, sorry. Okay, last thing, I know it's no longer less than normal, but the last thing we're going to do is give ourselves a key right here of how to know what the words mean when they don't just come out and say less than or equal to, is less than. So we already talked about at least. At least means it's that number, meaning equal to or more. So you do greater than or equal to. At most is the reverse, because it means it could be that number. That's why we use equals to, or less. So you can try just thinking about this. Like, I want my parents to give me at least $20. Well, that means you're okay with if they give you 30, but you're not okay with it if they give you 15. And you might say, at most, I'm okay with my teachers giving me 2 homework assignments. So you're okay if it's 1 or 0 or 2, but you're not okay with more. Okay, no more than. We put less than or equal to, because these two are connected. Because you think about it, you might say, at most, I'm okay with at most having 2 homework assignments. That's the same thing as saying, I'm okay with having no more than 2 homework assignments. So these two are connected, and so are these two. Because we go back to the allowance idea, or just money for going out, whatever. Saying, I hope they give me at least $20 is the same thing as saying, I hope they give me no less than $20. So at least and less than, at most, no more than. Now, the good thing is there's some similarities in the wording, most and more, least and less. But what's tricky is it's reverse of what you would think. Because the least and less actually turn into greater thans. the most and more turn into less thans. I know that's weird, but again, if you think about when we use a sentence with these, it does make sense.